All right, good morning. We are still working on Unit 4A practice test. This is part 2. This is going to be the video on radicals. So we're going to start with number 8. Show how each of the following expressions will result in a rational product. So we're taking the square root of 2 and multiplying it by each of these and showing that the answer is rational. So here with our square roots, if we can actually take the square root and come out with a whole number, then it is a rational number. If we take the square root and we can't come out, like we end up with the square root of a number that doesn't have that is not a perfect square, it will be irrational. So we're going to multiply A, B, and C by the square root of 2. Please note, these are not multiple choice questions right here. You're actually multiplying all three of them by square root 2. They're not, it's multiple examples of the same thing. Okay, so we're going to multiply. So 8 times the square root of 2 is square root 16. The square root of 16 is 4. So when you multiply radicals, you multiply what is inside the radical. Okay? Square root 32 times the square root of 2 is going to be the square root of 32 times 2 is 64. The square root of 64 is 8. And then square root of 2 times square root of 2 would be the square root of 4, which is 2. But something else that you might remember from rationalizing the denominator, if you multiply something times itself, it's squaring. This is the same thing as the square root of 2 squared. Now the square root and the square cancel and you're just left with 2. If that's throwing you off, you can also do square root of 2 times square root of 2 is the square root of 4, which is also equal to 2. So all three of those will result in a rational number. So remember, when you multiply radicals, multiply what is inside the radical. So 8 times 2, 32 times 2, and 2 times 2. Okay, number 9, show how each of the following expressions will result in a rational sum. So this one took me a second to wrap my brain around because I'm like, well, that's not rational, but actually, that is rational. The square root of 36 is 6. So remember, in order to add to get a rational sum, you cannot add an irrational number to anything and get something rational. So in order to get a rational number, it has to be a rational plus another rational. So when we add these, we have square root of 81 plus the square root of 36. Well, the square root of 81, I'm going to come down here. The square root of 81 is 9. The square root of 36 is 6. Add those together, you get 15. Then we have 7 plus the square root of 36. Well, 7 is just 7. Square root of 36 is 6. 7 plus 6 is 13. So this one, even though this one was a rational number, it wasn't in a radical. This one we simplified, so now we've got 13. And C, the square root of 36 plus the square root of 36. So we could add those together as radicals and say that's 2 times the square root of 36 because we have 2 of those. And then we can multiply this. What is the square root of 36? Well, we've said it a couple of times. That's 6. And then 2 times 6 is 12. Now let's say you went about this a different way. You took the square root of 36 is 6, plus this square root 36 is 6. Well, 6 plus 6 is also 12, so you get the same answer. So either way you approach it, as long as you approach it in a way that makes mathematical sense, you'll come out with the right answer. So when you start doing things that make no sense at all, that you get the wrong answer. Okay, let's turn the page. Okay. Excuse me. Okay, number 10. Show how each of the following expressions will result in a rational quotient. So quotient tells us we're dividing. So we're going to do this down here. I think we'll have a little more room doing it this way. So we've got the 15 times the square root of 48 divided by the square root of 12. Now the square root of 48 and the square root of 12 are not rational, so I can't take the square root of each of them. But what I can do is divide them and then take the square root. So 48 divided by 12 is 4. So this becomes 15 times the square root of 4. Well, the square root of 4 is 2. So this is 15 times 2, which is 30. Okay. B, we have 15 times the square root of 48 divided by square root 3. Okay, so I can divide both of these. These are both in the radical. 48 divided by 3 is 16. So this becomes 15 times the square root of 16. Okay, the square root of 16 is 4, so this is 15 times 4. And 15 times 4 is 60. And then we'll do this over here. So we have 15 square root 48 divided by 5 square root 48. This one's my favorite because the square root of 48 divided by the square root of 48 is 1. It cancels. And you're just left with 15 divided by 5, which is 3. Alrighty. So let's look at number 11. Number 11 is a adding and subtracting problem. So remember, if you want to add or subtract radicals, you can only add or subtract like radicals. So we have a square root of k, we have 2 square root k, and then over here we have another square root k. So I can combine those. 2 plus 1 would be 3. So we have 3 square root k. Now over here we have negative 4 square root m plus 5 square root m. So 5 plus negative 4, or 5 minus 4, is positive 1 times the square root of m. And I don't need to write the 1, I can just leave it as square root m. And that would be my answer. Okay, number 12. Simplify 2 times the square root of 10 times 5 square root 40. If necessary, leave your answer in simplest radical form. Okay, so we're going to multiply. When you multiply radicals, you multiply the two numbers that are outside. So 2 times 5 would be 10. And then you multiply what's on the inside. 10 times 40 is 400. All right. So if this were if this were imperfect, you could leave it here. But 400 is actually a perfect square. If you take the square root of 400, you get 20. You can do that in the calculator if you need to. Remember, you have a calculator on the test. Just remember, it wants it in simplest radical form. So if you give me some big, long, improper fraction, I'm not going to count it right. In fact, this is a unit test, so it's multiple choice. So that shouldn't be an option at all. So just double check that. All right, so I'm left with 10 times 20, which is a total of 200. Simplify the square root of 54 over square root 2. So I can divide my 54 and my 2. 54 divided by 2, I believe, is the square root of 27. Yes, that's right. Okay, so square root 27 is not a perfect square. So this is not simplest radical form, but it is radical form, so we can leave it here. I can show you simplest radical form real quick. Something you can do with these, if you want to simplify this further, is make a factor tree. Remember, square root, we're trying to find something times itself that gives us this number. Well, we don't have a whole number times itself that will give us 27. So what I'm going to do is I'm going to actually break this down into 9 times 3. Okay, I can't take the square root of 3, but I can take the square root of 9. And what's the square root of 9? It's 3. So this becomes 3 times the square root of 3. So both of these would be correct. Either one of these would be correct. Depends on how simplified you want to get. Okay. Something else you can do, since this is a multiple choice test, probably should not tell you this, but what you could do, this is to see who is listening to me and who is just copying the answers down and have the sound off. So if you're listening to me, here's a hint. You can take the square root of 27 in the calculator and get an irrational answer. Then, let's say this is the answer choice on multiple choice. You could put that in the calculator and see if it matches. Just saying. Something you could do. Just saying. Hopefully somebody listened to that. We'll see. All right. Number 14. We want to simplify this. It says leave it in simplest radical form. Okay. So, again, it's another division one. I would divide the 9 into 3 first. 9 divided by 3 is 3. Then here, 45 divided by 5 is 9. And then we still have m squared. Is that right? Yeah. Okay. So I divided the outside, then divided the inside. All right, so here, these are both perfect squares in here. So I'm going to leave this 3. The square root of 9 is 3. The square root of m squared. To get m squared, you have to do m times m. So the square root of m squared is m. Okay, and then we have 3 times 3m. That's going to give us 9m. All right. Number 15, simplify the square root of 5 over 7. Okay. So this, 5 and 7 won't simplify. I was almost tempted to say, oh, we would just leave this here. But remember, we don't want a radical in the denominator. I'm going to just abbreviate it. So no radicals in the denominator. So a lot of people are going to be like, well, there isn't one. That's just one big radical. This is the same thing. Square root of 5 over square root of 7. This is the same thing as this. We cannot have that square root 7 in the bottom. It's bad. If I ask you to take a Hershey bar and break it into sevenths, you could probably do that. If I'd ask you to break it into square root sevenths, you're going to look at me crazy. As a math teacher, that makes no sense to me. I don't know how to break something into square root 7 pieces. I don't get it. You can't do it. Or if you can, you're smarter than me. I don't get it. All right, so what I'm going to do is to make this a rational number, we're going to multiply it by itself. Well, if I multiply the top, if I multiply the bottom, I also have to multiply the top. Square root 7 over square root 7 is basically 1, so I'm not changing my number. If I didn't multiply both the top and bottom, then I would be changing my number completely because I would be multiplying by something other than 1. This will leave my number the same, but looking a little bit easier to handle. Okay. So we're going to multiply the top. Square root 5 times square root 7 is the square root of 35 over square root 7 times square root 7 is the square root of 49. And the square root of 49, well, what times itself gives me 49? We just did that. It's 7. So this is the square root of 35 over 7. Okay. And then square root 35 does not simplify further. I think that's as simplified as it will go. All right, and then the last one for this video. We have a rectangle has an area of 20 to the third times the square root of 15. This is the width. We need to find the length. So I'm going to kind of sketch this out real quick. So here's my width, my area. And then we don't know the length. So to get area, it's length times width. So something times this will give me this. So how do I undo multiplication? I use division. So we have 20m cubed times the square root of 15. We're going to divide that by 5m square root 6m. Yes, okay, I'm just double checking everything, making sure I'm doing this right. All right. And then we're going to simplify this to get the length. All right, so let's look at numbers first. 20 divided by 5 is 4. M to the third divided by m is m squared. This is where it's going to get tricky, is the radicals. Square root of 15 will not divide easily by square root 6m. So what I'm going to do, let's leave this like this for right now. And let's rationalize the denominator. Let's multiply by square root 6m. Okay? All right. So we're going to just multiply by square root 6m. 15 times 6, oh goodness, is going to be 90m. This will be 90m. So square root of 90m over 6m. Okay. All right. Okay, so we can simplify this a little bit further. I'm going to simplify the radical first. I could have divided earlier and that would have made things a little easier. I didn't think about it though. So to get 90, I have to multiply 9 and 10. 10 doesn't have a square root, but 9 does, and it's 3. So this is going to be, I'm going to bring this over here, 4m squared times 3 square root 10m over 6m. Okay. I can divide the 3 and the 6. The 3 will cancel. This will be left with 2. Then I can divide the 4 and the 2. This will be canceled, and I'm left with 2. And then m squared divided by m leaves me with just 1m. So this gives me 2m square root 10m as a final answer. Whew! That was fun. It was fun for me. I don't know about y'all. All right. So that is the end of the radical video. So part 3 will be geometric sequences. Part 4 will be exponential functions. Thank you so much for your attention. Hope you have a great day, and I hope this video series is helping you out some.